In this video we'll continue to write and add more functions to the smart contract or the handler itself, and then we'll test the function by writing a client application for that same. So we'll be able to submit a transaction from a Express.js application or a Node.js application to our transaction processor, which is like Battleship TP. So let's get into it. So the first I have checked out the second day branch. So day one branch, whatever we did on day one is day one branch. So day two today. So in this video, this is where we are gonna be focusing on. So as I told before, in this apply method we'll be writing the main logic for the code. It should always return a promise, and we should handle the exceptions and throw invalid transaction in case of any. If we are not handling any errors and then throwing it, the program will not execute any more transactions if there is any failed transaction in such case. So we'll import a invalid transaction from the Sawtooth SDK and throw some errors if we'll validate something from the input also. So for that, I'm gonna remove this code first. So in context we'll get three options basically. So under context we'll have set state, put state, get state, delete state. So I'm not sure about the exact name. So we'll basically get three operations in a smart contract. So every blockchain follows a similar pattern. So we'll get to modify the state with these functions. The state will look like a JSON. So this will be the state. In this state we may have value 1. So if in JavaScript, if you want to modify the value 1, you can easily do it by doing this. Or by doing this. So in a Sawtooth contract we'll be following this method to update the state. So any other value will be used, and this particular value will be replaced with a new value and will get updated as a new state. So this is what we are going to do in this code right now. I'm just going to return context dot set state. Let's change. Okay, so we need to generate address. For that, let's create a function. So let me go through the Sawtooth documentation to follow some pattern. So we'll use this function to generate a sample address. So this will create a string with the input we are giving. So I'll name this as hash function. So I have to create a hash address. So this is the place, this is the address where I have told this as a key. So to generate a key, I'm just gonna call this with the sample key and reduce the length to 64 characters. as we need to append the family namespace also. So here I have hard coded the family namespace, but we have to take the value of actual transaction family. So I'm just going to take a substring of 6 here. So we got totally 70 characters, which is the address we can store in Sawtooth. So we can store this as this, so because we need to send it as buffer, I'm gonna create a buffer for that. Let's take this as a object, sample key value. So this object will be stored in this address, which is generated based on sample key. So okay, sample key, sample value state. Okay, so now we can handle the response. Since we are giving this as an object with the possibility of any number of inputs can be given, we'll get the output as array. So we need to check if the array contains any output addresses. If it is 0, we'll throw internal error. So invalid transaction. I'm not sure where I'm imported from. So exception invalid transaction. So I'll throw invalid transaction error message here saying something happened. Well, there is very less chance of this particular code getting called, but this piece of code I'm writing in catch will get called if there is any issues while setting the address. So throw invalid transaction error dot message. So this will be logged in the validator, which will be running in the Docker. We'll see that. Right now our contract is ready, but to test this we need to create one more file, which is the client code. I'm going to do that using Express.js later, but now let's write a Node.js application to submit the transaction. So we can check the official documentation for the sample code. We can just follow the same way. Later we can refactor the code into sub modules and do a enterprise level solution. So I'm going to create a server code or client. In this case I will need a API, so initiating library like Axios. So Axios is my favorite. Haven't tried any other thing. So Axios, I should not get any errors. Okay, so we'll use this later. So building and submitting transaction. So I'll give the link in the documentation if possible, but you can get this from official documentation itself. So the first step is to create a signer key. Can be for application level or user level. This needs to be managed. Now we got a signer. Then we need a way to encode our payload. So here we are going to use just buffer. We need to send a string to the buffer, so I'm going to use stringify. Now we got our input payload bytes, so in byte format. So we will be sending this as a byte stream to the Sawtooth REST API. So we need to convert this as a buffer. So we need a transaction ID, so that that can be tracked in blockchain. So I'm gonna do that now. So we can mention any other dependencies in our project that we are not going to do right now, and input and output and family name. So we need to share this or generate the same way as if we are using contract. So I need to import this also. So to generate the same address, we can share the values in an environment file. Now we can use this same values from the environment variable itself. Same way for client also. We can only submit a transaction to one family version in a transaction, whereas in handler we can register this code for multiple versions of transaction processor. To generate address, let's generate address, or I can copy the code, same code. And you will need to give this in input and as well as output. So the input is where you get to access the input, checking whether the value exists using get state. You have to mention that address in the inputs. To modify a state or delete a state, you have to mention that in output. We can have multiple inputs and outputs, so that's based on the complexity of the code. So now we got our transaction bytes. So next step is to create a sign this branch, sign this transaction. So here we need to use the signature or the private key to sign this transaction. So this is our one transaction. We need to we can create more transactions like this and create a batch and more batches like that and create a batch list and then submit to the TP. So all this batch list will be creating more batches, and all these batches will contain more transactions, and every transaction will try to get executed. And only if every transaction in a batch gets completed, the batch gets added to the chain. Now let's create a array of transaction. Then an array of signs, so sign the batch. Since the same variable name is being used everywhere, just gonna reassign the values. So anyway, it doesn't matter in this application. They have some common code issues, so we need to create a PR to modify this later. Let's encode them and assign them as well. So we have created a transaction first, then transaction list, from that then batch, then batch list. So I'm gonna do the Axios API call. To Sawtooth REST API. So each Sawtooth REST API will be connected to a particular validator. So this transaction is gonna get committed to a validator. Post. So the URL is default HTTP localhost 808, so 8008. Batch. Then the data will be batch list byte. Then this is going to be the header. So we can handle the response here. So whatever the response you are going to give back here will be given to here in the final response. We'll be getting a link if the batch got submitted. The status will be pending, committed, or rejected. So to test this code, we need a single function to start the code. Index.js. I'll rename this to contract, and I'm gonna create an index.js. npm install. So I want to run this in development mode so I can restart the code whenever it gets changed. I'm installing Node1 for that. I'm gonna modify this program a bit. So there is some package changes it's not able to remove. So I'm gonna remove the npm packages, install it again. In this code, we are going to require the contract first. Then client. Okay, so I think we don't need to do this right now, as This is not a express API. This will get initiated as soon as the code starts, so we don't want to do that. We want to wait until the contract gets deployed. So I'm not gonna do this right now. Let's just keep it here. So let's download the Docker Compose file so we can run the code. Going to Sawtooth core. We can download many types of Docker samples from this repository itself inside a Docker Compose directory. We are going to use default one. Exploring these two TPs, this is enough for us. I'm gonna start the Docker Compose. Right now I'm using Windows to run the code. I have enabled WSL, Windows System for Linux, so I'll be able to run Linux. So I can, as you can see, I'm running Ubuntu 18.4 inside Windows. I'm using Docker installed in Windows through this WSL on Linux environment, so you will be able to run and develop the applications on any environment right now, because Windows, Mac, Linux, everything supports Docker. Node. Okay, so before that we need this Docker Compose up. So by default this will pick the Docker Compose file. Since I have already pulled some of these images, such process is a bit faster. Have a good internet connection. This will take more time for you. So this week Hyperledger Fabric 2.0 has been released. The way we are going to run the code is the same way you will be running the Fabric code also, because right now we don't have to be on the host machine to install the contract. We just need the API endpoint, so the TCP endpoint. The same way you will be able to install contract in a remote machine in Hyperledger Fabric 2.0 onwards. So client, node contract. Okay, the battleship has been registered. Let's verify the transaction or the code itself. Client, error. Okay, so the documentation is still out of date, so we need to call new crypto factory. Hash is not defined, so let's call this hash function. Exports hash. Okay, so I think I need to copy and paste the client. What happened to your client? Hash is not okay. Hash is not imported. Okay, now our first block has been completed and it got submitted. Let's check if the batch is committed. So this is the response we'll get from the state: invalid resource ID. Voila. So things seems to be working right now. So I'm registering the contract with Battleship 1.2 and running the client, and the block is getting generated here as well. So we are generating the blocks whenever there's a state change. So we are all set. This is our basic contract. We can add more logics in this area. Before setting up a state, we can decode and check the payload in the transaction block. So we'll do that in the next class. So if you have any comments for this class, do share it. When I make the next class, I'll try to improve and make it a better one. So thanks for staying in. Until next time, tada, bye bye.